guys, happy Friday. Today we're working on 3.02, classify, add, and subtract polynomials. Hi, so your warm-up today is which one doesn't belong? Make sure you put your reason in the show your work box. So go ahead and take a minute. You guys can graph them or do whatever you think is the best way to figure out which one does not belong. Okay, make sure you give me your reasoning. Remember, there's no wrong answer for these ones. Okay. Today's goals is what is a polynomial? Okay, so we want to be able to define a polynomial, determine the degree, name a polynomial based on the degree and the number of terms, rewrite polynomials in standard form, and add or subtract polynomials. So the first thing we have here is polynomials can be an expression of one or more terms. Okay, so it's the only requirements for being a polynomial. So here are some examples of polynomials. Okay. So here are all monomials. Okay, so a monomial mono means one. So it has one term. So each of these things are one term, meaning they are a monomial. Okay, then these are binomials, so each of them have two terms. Okay, meaning that there is an addition or subtraction sitting between both of those terms. Okay, so those are called binomials. Trinomials have three terms, and anything above that is called a polynomial, meaning that it has many terms. Okay, things that cannot be polynomials are fractions. Okay, there cannot be any denominators in a polynomial. So keep that in mind. Okay, naming a polynomial. So here's another chart for how to name them. So again, monomial, binomial, trinomial, and polynomial. Those are the four names for the number of terms. We can also name name polynomials based on the degree. So if it's just a number, remember we call that a constant. Okay, if its degree is 1, meaning the exponent on the x right here is 1, it's linear. If the exponent is a 2, then it's quadratic or degree 2. Third degree is cubic, which means it has a 3 as an exponent, and you always want to look for the highest exponent. Okay, 4 is quartic, and 5 is quintic. And I think there's more, but anything other than that, you usually just say 6th degree, 7th degree, so on and so forth. All right, so it says, which of the following are not polynomials? So we want to circle the ones that are not polynomials. I'm going to go ahead and zoom in on them. Okay, so this one, okay, remember the things that are not polynomials. I actually think it's probably easier to start with which ones aren't. Okay, so we want anything that is not a fraction. Okay, so we don't want any fractions. So if we look right off the bat here, we can see the second one down is not a polynomial. Okay, you can't have x's in the denominator. Now, this one right here is a polynomial, okay, because none of those x's are in the denominator. Okay, all of those fractions are coefficients. So this one is a polynomial. Okay, the first one's a polynomial because there's no fractions. We also cannot have square roots. Okay, so that's not a polynomial. This one is a polynomial. This one's a polynomial, not a polynomial. This one is. This one is. Okay, the only other one that I see here This one is, this one's good. This one has a variable in the denominator, so it's not a polynomial. Okay, the last one that we have to look at here, this one right here, since it has a fraction as the exponent, what that turns into is a square root. Okay, so that is not a polynomial. Okay, so you don't want fractions, you don't want negative numbers as the square root. And guys, I typically Google it. Not polynomial. Polynomial examples. And usually we can find a pretty good picture of the ones that are not. Okay, so here's two things that are not. So it can't have a negative, it can't be in a fraction. You can't have a fraction as the numerator or as the exponent. You can't have a square root. Okay, so those are your four things. So no variables in the denominator, no negatives as your exponent, no fractions as your exponent, and no square roots. Those are the four things that you cannot have. Okay, now let's try to see if we can identify these based on the degree. So it says, what is the degree of each of these? So remember, the degree is the highest exponent. Okay, so if we look here at A, the highest exponent I see is 3. So that's the degree. It would be cubic. Okay, in B, the highest degree would be this n because the exponent on the n would be a 1. The next one, highest degree or highest exponent is 3. So degree 3, so it's cubic. And this last one, if I look at for the highest exponent, it is 4. So it is quartic. Okay, some reminders. Degree of one term is a monomial. Add the exponents. You do not add the exponents to get the term, the degree, unless if it is a monomial, you add them. But only if you can. Okay, I'll show you an example of that. All right. Practice number 3, it says write this in standard form. So what standard form means is we want to write it from the greatest exponent to the smallest exponent. So I'm going to go ahead and copy paste. And it doesn't work, so I'm going to delete it. So we want to look for the highest exponent first. Make sure you take the sign with it. So the highest exponent I see in here is 2. And these really both have 2. Okay, but they're also not like terms because they don't have the same variables in them. So I would put the one with multiple variables first. Okay, then you have plus j squared. And then you can combine your like terms. Okay, so 8 plus 3 gives us 11. And that's what you're going to type in here. Okay, the next one. We want to put in standard form as well. So we want to find the highest degree. So I think this is where they're trying to say that the highest degree is when you add them together. Technically, that is only true if the variables are the same. Okay, so think about our exponent rules. If I had 3x, x to the third and x to the third, then that would be x to the sixth. But you can't really combine them if there's not. However, we will use that method just for the sake of putting these in standard form. So if I look here, this degree, if I add those two exponents together, would be 5. So that is our highest degree. but you cannot combine those because they are not the same variable. The next highest would be y to the third because its degree is 3. So that would be plus 4y to the third. The next highest degree would be the second power. And then always remember x has a power of 1, so it'd be less. So we get -2, x to the third, y to the second, plus 4, y to the third, minus x to the second, plus x would be standard form. Okay, last one. So again, we want to look for the highest degree. So this one's tricky because there's two things with the same exact degree. Okay, typically when you're putting things in standard form, guys, it will not have two things that are the same degree. Okay, and if it does, they should both be x's and you can combine them. So we'll go ahead and leave the x first. So I don't know why I was plus, it'd be 4x squared plus a squared. And then we can combine that -5x and -2x. And that degree is only 1, so it has to be on the end. Okay, looking at the next one, we want to classify the polynomials. So first thing, all of the first names are based on the degree. So if we look at this first one, it says, we want to look for the highest exponent. So the highest exponent I see is a 5. So that means quintic. And the second part, polynomial, means it has more than 3 terms. And you can see here it has 1, 2, 3, 4 terms. This one we see highest degree is a 3, so that's cubic. And if I count the number of terms, that's 1, 2, 3 terms, which is a cubic trinomial. And lastly, my degree on the V is 1, so that means it has to be linear, and it's only 1 term, so it's a monomial. Next piece is to add and subtract polynomials. Okay, you guys have basically been doing this all along. Okay, adding and subtracting polynomials, you're combining like terms. Okay, so that's exactly what addition is. It's combining your like terms. There's nothing different than what we've already done. Subtracting polynomials just means that we have to distribute the negative first and then combine our like terms, which again, you guys have already done. So let's go ahead and look at the first example. So we want to add these. So again, combine like terms. We see we have 14a squared and a squared. So remember that would be 15a squared. And -10, -13 would be -23. So if you put this together, this is really tricky. I wonder which one they wanted in. I would say 15a squared minus 23 to put it, then it's also in standard form because your a squared should come first. Next one, okay, this one's adding as well. So again, you're combining your like terms. So 3 and 3. Okay, and then we have our constants. Nothing else can be combined. I would also put it in standard form. So start with the highest degree. So the highest degree is 5. So that would be -14 p to the 5th because you want to take the sign and the coefficient with it. Next would be 4. So it would be plus 4p to the 4th. Then I have to combine my p cubes. So -7 plus -9 is -16 p to the third. And last but not least, 8 minus 3 is 5. So if we go ahead and put that in there, we get -14, +4, -16, and +5. Then we have some subtraction. Okay, so subtraction, the only thing different is you need to make sure you distribute the negative first. Okay, and how I do this is I just go ahead and put the negatives in the parenthesis and then change it to positive. Because then once you distribute that negative, you're combining your like terms. Then we can go ahead and combine. We have -14 and now a -2. So that is -12 and then -2, which is -14 x squared. And 7 minus 1 is +6x cubed. And I already see that I put a squared here. That should be to the 4th power. So we get -14x to the 4th plus 6x to the 3rd. Last one here. Again, I always just distribute the negative right away. And remember, distributing a negative just changes the sign. So a double negative here would make this positive, make this negative, and make this positive. And then we can treat it like combining like terms. So we can combine our like terms. The 5th is the biggest power. So it's going to be quintic. So 11 plus 9 is 20, and to the 5th. Then we have to the 4th power. So that would be 12 plus 5 is 17, n to the 4th power. And last but not least, we have our n's. So 12 minus 3 is +9n. That gives us 20 plus 17 plus 9. Okay, so your guys' homework for today, this is not your homework, okay? I will post your homework assignment on OHS as well in the announcements. Have a fantastic weekend, guys, and I will see you guys on Monday.